All right. So we got one more lesson today, chapter 2. Tomorrow will be a review day over everything we've done in chapter 2 up to this point. And then Friday we'll have a quiz over those first 3 sections. Even though we spent 4 days on it because we had 2 days on 2-2 with the story problems. Today is a topic we've done a lot before, but one thing I will tell you today is we're going to write our answers a little bit differently than what you've written it in the past. So we're still going to solve inequalities, and that part I think will be pretty familiar to you. But the one part that will be different is how we write our answer and how we express our answer. We'll talk about that as we go. First of all, inequalities. If I write out x is less than or equal to -4, then we're going to write our answer 3 ways. And so most of the problems that you do today, you're going to have like 3 parts to them, okay? And we're going to write it or express it 3 different ways. And so the first way that we're going to write our answer is what we call set builder notation. And basically we're going to put it in a set. So you make these brackets. And this one is essentially already done because it's already solved. X is already by itself. And so the way that we would read this is for all values of x, then x is less than or equal to -4. So this slash right here is just kind of a barrier saying for all values of x, then x is less than or equal to -4. Okay, so once you have it solved, once you've solved your inequality for whatever variable you're solving for, and we'll do some solving today. I'm just giving you one here that's already in inequality form. Then we'll just put it in that set, okay? And this is the answer for our set. Kind of like what we did last week when we put like, or last chapter I should say, when we put like numbers in a set. When we did like integers and whole numbers and things like that, and we wrote out the set, we used those brackets to enclose it. Okay, now the part that is going to be a little bit different is what we call interval notation. And then we're going to graph it on a number line. So those are going to be the 3 different ways that we're going to express our answer today. Well, interval notation is not something that we've ever done before, okay? But I will tell you that if you go on to take college algebra, then college algebra uses interval notation a lot. So this will be kind of an introduction into it for those of you that go on and take college algebra at some point in time. So basically what happens here is we don't use like closed circle, open circle anymore. Instead, we use 2 different symbols. For interval notation, we use either parentheses or we use brackets. Okay, parentheses means not included, which would be the same as an open circle that we've used in the past. Brackets means we are including that number, and that would be the same as a closed circle that we've used in the past. So we're not going to use any closed circle, open circles today, okay, like what we've done before. We're going to use all brackets and parentheses on our number line. And what I'm going to show you here is I think it's easier to do the number line first and then do the interval notation, and I'll show you why. So I think this is the order that they ask it for, so you don't necessarily have to do it in this order. I like to do the number line first and then come back to the interval notation. Okay, so as we look at this one, I'm going to make a number line here. We're going to place -4 on the number line, and you don't have to get real crazy with your number line. Usually I like to show where 0's at. -4 is a little bit to the left of it. And then we're gonna shade this, right? And the shading is what we've done before, but we're just gonna put something different at -4. So in the past, I would have always put a closed circle here going to the left, right? Everything less than or equal to -4. Well, for today, what we're gonna do is instead of a closed circle, we're gonna put a bracket, because bracket is the same as a closed circle, okay? And it's less than or equal to, so we're gonna shade it all the way to the left forever. And then I always like to put an arrow on the end to show it's gonna keep going in that direction. And that would be our graph, okay? So biggest difference is this replaces the closed circle, okay? And you're always gonna open it in the direction that your graph is shading. If I was shading to the right, then I'm gonna open my bracket to the right. So that's why I put brackets opening either way, or parentheses opening either way, depending on what my symbol is for my inequality. So then the last thing is interval notation. What's that gonna look like, okay? Well, if I was to say, how far is this graph gonna go? How far left is this graph gonna keep moving? Forever, right? It's gonna keep going forever. And so when we talk about that, because this is a number line, this is -infinity all the way to the left, positive infinity goes all the way to the right. So when we think about our number line, it goes on forever, okay? I could keep adding numbers and keep going as far as I wanted to go. So this graph is gonna go from -infinity, because we always move left to right, we're gonna go from -infinity all the way up till we get to -4, okay, as we move left to right. But I can never stop at -infinity. -infinity goes on forever, right? And so because there's no stopping point, we're going to use a parenthesis, and we're going to say -infinity all the way up to -4, and we're going to put a bracket. And that's our interval notation. And that's the way we would read it. All numbers from -infinity all the way up to -4, including -4. Okay, questions on that one? Okay, let's do more where I'll give you just a simple inequality. We're not solving this, and then we'll move on and we'll do some where we have to solve it and do some of those kind of things. But for right now, we're just going to express our three answers in the three different ways it's going to ask us to do it today, just so we have some practice doing that. Okay, in this case, it uses a different variable. Okay, I can use whatever letter I want to use for a variable. So in this case, it uses n. N such that n is greater than 3. So for all values of n is bigger than 3. Okay, then we're going to do interval notation, and we're going to graph it on a number line. Okay, so for this one, when we do the number line, we know 3 is our starting point. Our symbol is greater than. So what symbol do you think we're going to use here? Parenthesis or bracket? Those are our two choices. Parenthesis, right? Because we're not including, okay? We're not including this one. And we're shading to the right, so we're going to open our parenthesis to the right. So this one would be a parenthesis, and we're going to shade it to the right. 3 to the right forever. Now, here's where it's going to be just slightly different. This one's going to the right, so it's going in the positive direction, right? So when I do my interval notation here, this time, as I move left to right, we're going to start at 3, and at 3 we have a parenthesis. So we're going to go parenthesis 3 to infinity. Infinity will always have a parenthesis next to it because you can't stop at infinity. You can't include infinity. It's not an actual number. And so we're just going to go 3 to infinity. Okay? Questions so far? Okay, the first solving one. Negative 6x is less than 30. Okay, I kind of gave you a little bit of a tricky one to start with, but this is something we got to really be careful of as we go throughout the day today. As we solve this one, what would be our step to get x by itself? Divide by negative 6, okay? Just like we've done with equations. We've solved a lot of equations the last couple of weeks. Here, we're going to divide by negative 6. We're trying to get x by itself. But here's the trick you got to remind yourself. When we do inequalities, if I multiply or divide by a negative, what do I got to do? You got to flip the sign, okay? Now, I think that sometimes, you've probably heard that rule before when you've solved inequalities, but maybe you don't truly understand why we flip the sign, okay? We're trying to find out what values of x make this true, right? Just like an equation. Well, here there's a lot of things that make this inequality true. With an equation, usually there's just one thing that's going to hold true, okay? With an inequality, there's lots of things. So if I didn't flip my sign, then we're going to say everything less than negative 5 would work. Right now, we're saying anything bigger than negative 5 is going to work. So I'm going to pick a number out that's bigger than negative 5, okay? And I'm going to try to pick something really easy. 0 is my go-to. If I can use 0, I'm going to use 0 because 0 is so easy to use, right? 0 is bigger than negative 5. What's negative 6 times 0? 0. Is 0 less than 30? You bet. Okay, so it works. If I had not flipped my sign, this would say x is less than negative 5. That means anything to the left of negative 5 would work. So a number like negative 6 would work. But if I take negative 6 times negative 6, I get 36. Is 36 less than 30? No. Okay? So that's why we have to flip the sign. If we don't flip the sign, then our answer is not going to work. Okay? And so what we're saying here is that all numbers bigger than negative 5 would be a solution to this inequality. So I have tons of numbers I could plug in here and check. So we can still check this, just like we've talked about with equations. I can still look at my answer and I can see, does this work or not? But you have a lot of things you could check rather than just one number that we have to check. Okay, and then we can write our answer in our 3 different ways. Very similar to what we did on the last one. Okay, number line, negative 5. Okay, parentheses or brackets here? Parentheses, okay? Basically, if I have an equal sign under here, and this is the way I remember it, if I have an equal sign under here, then I'm going to square it off. I'm going to make a bracket. But if there's no equal sign under here, then it's just a parenthesis. And we're going greater than, so we're going to the right. And here's why, and I've kind of talked about this before, but here's why I like doing the number line first. If I've gotten this graphed, now putting it in interval notation is pretty easy. Because as I move left to right, the first time I run into my graph is at negative 5, right? And there's a parenthesis at negative 5. So we're going to go parenthesis, negative 5 to infinity, and both of those would be parentheses. Okay, another one that sometimes gets missed, and we'll talk about, I'm just going to talk about a lot of different things and common mistakes that are going to get made here, okay? So, first up here, we're trying to solve for m. And so we're going to get m by itself first. So what would we do first? Subtract 2, right? So we're going to subtract 2 from both sides. So we get negative 12 is less than or equal to 3m. And then we're going to divide by 3. We never multiplied or divided by a negative. So that's the one thing you got to keep in the back of your mind. If I multiply or divide by a negative at any point in time, that's when I flip the sign. I haven't done that yet, so my sign has not flipped. But with the variable being on the right, we always want to finish with the variable on the left so that the sign is going to point in the direction that we're going to shade. Because if you tried to shade this one right now, more often than not, you're going to read this as less than, and you're going to think that you're really shading left. But we always want the variable to end up on the left-hand side. So I'm going to flip everything. I'm going to flip M to the left. I'm going to flip my sign. And I'm going to flip -4 to the right. Okay? So we're just going to switch everything. Because it's a lot easier to read this as all values of M is greater than or equal to -4. So we know that we should be shading to the right. But that's a very common mistake is if I don't put the variable on the left, I might shade the wrong way. And then once again, oops, I did the interval notation first. That should be, I should have done the number line first. Okay. We're going to start at -4. It's equal to, so we're going to do a bracket. Make sure you can tell the difference between bracket versus parenthesis. Brackets squared off versus parenthesis is rounded. And then we're going to shade to the right. And then once again, -4 to infinity. Okay, let's look at one that's a little bit longer, okay? And this kind of goes back to very similar, the ones that we have done with equations. We got a lot of different things going on here. But once again, ultimately our goal is to get k by itself. We just got a lot of stuff going on here. But we're going to solve it just like we've done equations. Bless you. So what are we going to start with? First step's got to be what? Distribute, right? If I see parentheses with a number directly in front, then we got to distribute. We got to distribute this too. Okay. Now on each side, we want to combine like terms. We got some k's on the left, we got some k's on the right. So 2k and 4k make 6k. On the right, 7k minus 5k. And now we're going to get our k's together. So because we're going on opposite sides of the inequality, I'm going to subtract 2k. Addition and subtraction never makes me flip my sign. So if I subtract 2k, that's okay. My sign's going to stay the same. So we now get 4k is less than or equal to 16. K is less than or equal to 4. Okay. So a few more steps, obviously. But nothing that we haven't seen. The only thing different is we add an inequality to it. Okay, and once again, we write our answer in our 3 different ways. Okay, this time it's equal to, but it's going to the left. So my bracket is going to be up to 4, but we're going to open it to the left and we're going to shade to the left. The bracket or parentheses is always going to open in the same direction that we're shading. So as I write my interval notation here, what's going to come first? Where are we going to start with? As I move left to right, how far left is this graph going to go? Infinity, right? And we got to remember that all the way to the left, we call that one negative infinity. All the way to the left is negative infinity. All the way to the right is positive infinity. So we're going to say negative infinity all the way up to 4 inclusive. Okay. The next couple, I'm going to show you a couple that look very similar to what we just did, but I'm going to show you as you work through them, something different kind of happens, and I want to kind of talk through these and show you what the answers would look like and how we would express it. Okay, so we want to solve here. Very similar to the last one, right? We see parentheses, we see variables on both sides, so a lot of very similar concepts to what we just got done doing. So we're going to take the 4 and distribute it. Combine like terms. And then when I move my x's to either side, the 9x's disappear. Okay. So with an equation, we would have said this can't happen, right? Negative 8 and 12 are not the same, so that would not be true. But this one is an inequality. So we have to ask ourselves, is this inequality true? Is negative 8 less than 12? Yeah, always, right? And so the way that I always like to do this is I will say something like, that is always true. Negative 8 will always be less than 12. So what numbers do you think would fit this inequality? Any ideas? Hudson? 1? 1 would work? Okay, is that it? Just 1? 1's the only number? Any other ideas on a number that might work? 8? Okay, why'd you say 8?
Less than 12.
Okay. What about 20? Would 20 work here? Do you want to check it to see if it works? Probably not, maybe, right? Yeah?
All real numbers.
All real numbers, yeah. Because this is always true, and that's why I like to write it as always true, all real numbers are going to work here. Because everything that I try to plug in here would work. Any number. It could be a fraction, it could be a decimal, it could be 20, it could be 100, it could be anything I want it to be. Any number that I plug into this inequality for x will always work, okay? So yeah, 1 works, 8 works, any of those things work, okay? Now, how do I express that in these? Okay? I'm going to say x such that x is in the set of all reals, all real numbers. Last year in Algebra 2, you might have used that symbol. It's like an R with a line through it, and that's the symbol for all reals that we sometimes use. You might have seen that before. So there's a lot of different ways that you could express that, okay? But we're just saying that everything works in some shape or form. if I was to do it on a number line, what would that look like? What numbers would need to be shaded here? How far left am I going to go? Yep. How far right am I going to go? Infinite, right? And so my graph is just going to be arrow, arrow. My interval notation is going to start at negative infinity, and it's going to extend all the way to positive infinity. Everything in between is going to work. Okay. So this is another way of saying all real numbers, but it's an interval notation. Okay. So just know when you see that, it means all reals. Okay. The other one look very similar. Okay, this time we have some T's. I don't always like using T's because that's why I kind of like put a little tail on my T's so we can tell the difference between T and the plus sign. We're going to distribute, okay? And what we got to be careful of here is this would be like a -1 directly in front of the parentheses. Okay, we are not distributing the 7. We're distributing the -1 that sits right here directly in front. So be careful of things like that. We are going to distribute here. Combine like terms. So this would be like a -1t plus 6t, which would be 5t. And then 7 minus 4 would be 3. Okay, this looks very similar to the one we just did, okay? But it is quite a bit different. And here's why. Here's the part that's the same. If I subtract 5t from both sides, I get -15 is greater than or equal to 3. So our t's disappear. We have this inequality that's left. And so we're going to look at this and we're going to ask ourselves, is -15 greater than or equal to 3? When will that be true? Never. Okay, not today, not tomorrow, never. This will be never true. And if it's never true, then what values are going to make this true? This is just the opposite of what we just did. Do what?
Is it imaginary number?
Nope. Nope. Not 0. You really want to get into imaginary numbers, huh, Hanson? It's your favorite?
No.
What's going to work here, guys?
Nothing.
Nothing, right? Because if it's never true, there's nothing that's going to make this inequality true. That's why I like to write those words there, never true. Nothing will make that true. There is no number I can plug into this inequality that's going to make this true. So as I look at my sets here, this means empty set, okay? No solution. Nothing works. T such that no numbers work. What do you think the number line is going to look like here if no numbers work? It's just empty, right? It's just a number line with nothing on it. It's just an empty number line, right? No numbers on their work. And for this one, we would say the same thing. No solution. Okay? No interval notation because there's no solution. All right. Last thing, you're going to see a problem like this today on your assignment. And this is kind of showing you where you might use an inequality in a situation or a real life situation. Okay, we have a student that got an 84, a 92, and a 94 on their first 3 test scores. The student knows that if they get an 89.5, the teacher will round that up to an A, and they'll have an A for their average. So the student wants to figure out what does she need to get on her 4th test to get at least an 89.5. So 89.5 or above. Okay, so how do we find the average of something? Yep. Okay, so we're going to do 84 plus 92 plus 94. Now here's the trick. Okay, we don't know what that 4th test score is, but we're going to add it in, okay? But it's an unknown. And because we're adding that 4th test score in, we're going to add it up and divide by 4. And we want to score at least an 89.5 average. So what inequality would we want? Greater than. And what about equal to? Would equal to work? Because if I get exactly an 89.5, I can get it rounded up. So that's our inequality. Okay? Add them up, divide by how many test scores there are, and then set it equal or greater than or equal to, in this case, to the score that we're looking for. Okay? Now we got to solve. What would I do first here to solve? Okay. Yep, I'd be good with that. Let's add these together. 84 plus 92 plus 94. What do those add up to be?
270.
Okay. 270 plus x divided by 4 greater than or equal to 89.5. Okay. Now, we can't just divide 270 by 4. Okay. So because this is a whole expression up here, we can't divide them by 4. You could divide both of them by 4, but then we have fractions and no thank you, right? So what would be the better way to get rid of the 4? Multiply it. Yep, we're going to multiply on both sides. We want to get rid of that fraction, so we're going to multiply by 4 on both sides. So we're going to go 270 plus x 89.5 times 4. What's that give us? 358, okay. And then we subtract 270. Okay, so the student must score at least an 88 to get up to that average level. Okay? And if you want to see, well, does it make sense? They had 2 A's on on these 2 tests, right? But 84 is kind of what's hurting their average a little bit right now, right? If you get down to this right here and because I've had some people do this before, like especially when we get to the finals at the end of the semester and Mr. Root, I got to get 103 on my final to get a B. It's going to be kind of hard to do, right? That may not happen because I'm not giving any extra credit on the final. So that does happen where you might get a number bigger than 100, and that would be what we call impossible. So unless there's some kind of extra credit offered. But this would be doable, right? Getting an 88 would be a doable situation. All right, here's the assignment for today. Most of these are going to have the 3 parts to them. The last 2 are the kind of story problems like what we just did. You don't have to do the 3 parts on those 2. Number 52 and number 48, you just have to write the inequality out and solve it. You don't have to do the 3 parts on those 2. Okay. So 8 through 44 are the ones you have to do the 3 parts on.